Solving equations using the log laws and the deductions. So in the first example, we asked to solve for x, and we have 2 to the x equals to 5. You notice that x is in the exponent. For me to be able to solve x, I'm going to introduce logs on both sides. So I'm going to actually do this question using two methods, but we get to the same result. So in the first method, I introduce logs. So what I write is log of 2 to the x equals to log of 2. And the reason why I'm doing this is because I want to use the power rule that allows me to write x log 2 equals to log 5. So this is by introducing logs, I can then get the exponent using the power rule to become a number, and then I can solve for the variable x. Now, you may only introduce logs in an equation if you have one term on the left-hand side equals to one term on the right-hand side. So I want to get to x, I need to divide both sides by log of 2. So we divide the left-hand side of our equation by log of 2, and we divide the right-hand side of our equation by log of 2. And so log of 2 divides into log of 2 once. So I have that x equals to log of 5 divided by log of 2. We enter this into our calculator, and we see that the answer is 2,321928,095. I'm going to round off to 3 decimal places, so my answer is 2,322. There is another way in which I can solve the same question. So I'm going to write down the question again. So I have 2 to the x equals to 5. I can immediately change this into log format, remembering that the base of the exponent will be the base of the log. So I need to get to the exponent, and the exponent is x equals to log of the number 5 to the base 2. Now you enter that into the calculator. Remember, that is a different button on your calculator. And you still get the result of 2,322 if you round off to 3 decimal places. Question 2, we now have that log of x to the base 5 equals to 2, and you want to work out what x is. So you must find the number that when you take log of that number to the base 5, you get 2 as an answer. So what I'm going to do now is, for me to get to x, I need to remove the log, so I rewrite it in exponential form. So x is going to be 5 squared, because the base of the log is the base of the exponent. So I get that x has to be 25. Now we come to quite a complicated question. It says here the log of x must equal to 1. Now, when I see the log and I see log x, I know that the base is 10 because this is a common log. I'm going to use a method called k substitution, and I'm going to let the log of x equal to k. So I rewrite this as the log of k must equal to 1. Now this is the common log, and I know that the base implied here is base 10. So if I write it in exponential form, I see that k equals to 10 to the 1, which is 10. But remember, I substituted log of x to equal to k, so I'm going to resubstitute. So I get that the log of x equals to 10, because k is 10. Now again, it's a common log and the base is 10. For me to get it to the value of x, I'm going to again change it to exponential form. So I get that x equals to 10 to the exponent 10.